17 days. That was the time between the Soviet decree authorizing the Su-85 and the start of serious production. 17 days sounds like a triumph of wartime industry. It was also a confession. The Red Army had found a gun that could kill a Tiger, but it did not have time to build a vehicle that could survive one. So the Soviets built the Su-85 around a single assumption. The Soviet crew had to see the German tank first. Because the Su-85 was not really a dueling machine. It was a gun mounted on a prediction. By the autumn of 1943, that prediction had become urgent. A Tiger's frontal armor was roughly 4 inches thick. Its turret face was similar, and the mantlet around the gun was heavier still. The standard Soviet 76mm tank gun could not reliably defeat that armor at any distance where the Tiger's 88mm gun was not already lethal. This was not a close contest. It was a range problem, an armor problem, and a time problem. The Red Army had already tried to solve it with the SU-122. The SU-122 carried the 122mm M30S howitzer in a fixed armored casemate. It could smash field positions, buildings, and infantry strongpoints. But a howitzer designed to throw heavy shells in a high arc was a poor tool for hitting a moving tank before that tank fired back. Its projectile was slow. Its direct-fire anti-armor range was short. Its two-piece ammunition and screw breech held the practical rate of fire to roughly 2 rounds per minute, and its frontal armor was only about 1 3/4 inches thick. To a Tiger's 88, that was not protection. It was delay. A shape charge round existed, but early Soviet fuses and warheads were inconsistent. Against a stationary target under ideal conditions, the Su-122 could be dangerous. Against a moving heavy tank that had already seen it, the crew was gambling with a weapon that took too long to correct a miss. The Soviet answer was brutally practical. Stop forcing a howitzer to behave like an anti-tank gun. Use a real high-velocity gun. The weapon already existed. It had simply been aimed at the wrong part of the sky. The 85mm model 1939 anti-aircraft gun, known as the 52K, had been designed to throw a shell thousands of feet upward at fast-moving aircraft that required high velocity, a flat trajectory, and heavy energy at the muzzle. Those were also the qualities needed to punch through armor. The Red Army already had the gun in production, and now it had something else. An intact Tiger. German heavy tanks captured near Leningrad were used for live-fire testing. Soviet crews placed one in front of the 85mm weapon and recorded the result plate by plate. Against the side armor, about 3 1/4 inches thick, the 85mm armor-piercing shell broke through at approximately 1,600 yards. At closer range, the damage was not a neat hole. The rear face of the plate tore open, throwing fragments inward. Against the lower front plate, roughly 4 inches thick, the gun penetrated at about 1,100 yards. But at 1,600 yards, a shot against the upper front did not go through. It drove a deep crater into the plate and stopped. The test commission reduced all of that steel, noise, and shattered armor to one conclusion. The 85mm gun could defeat a Tiger from the side at roughly 1,600 yards, and from the front at roughly 1,100. That sentence did more than describe a test. It created the Su-85. The Red Army now possessed a weapon that could kill a Tiger. What it lacked was a way to move that weapon with a mechanized formation. 2 design teams were ordered to solve the problem. Between July 25 and August 6, 1943, competing vehicles ran at the Gorokovets Proving Ground. They covered hundreds of kilometers and fired hundreds of rounds. Vasily Grabin's bureau entered a design armed with the S-18. Fyodor Petrov's team at Factory No. 9 offered the D-5S. Another direct descendant of the 85mm anti-aircraft family. The S-18 entered the trials with powerful institutional support, but the D-5S matched its ballistic performance and proved more reliable. The commission chose Petrov's gun. The vehicle was accepted on August 7. On August 8, the State Defense Committee authorized production, and on August 25, serious manufacture began at Uralmash in Sverdlovsk. 17 days. That speed was possible because the Su-85 was not a clean sheet design. It was a wartime substitution. The chassis came from the T-34. The fixed superstructure came from the Su-122. The V2 diesel engine was already familiar to Soviet factories and crews. The gun had already been developed from an anti-aircraft weapon and was being adapted for other armored vehicles. The Soviet state did not pause to invent an ideal tank destroyer. It assembled an available one from parts already moving through the industrial system, and every major weakness of the Su-85 came from that decision. The first sacrifice was the turret. The gun sat in a fixed casemate and could move only about 10 degrees to either side. 20 degrees in total. A turreted tank could follow a target across the battlefield without moving its hull. The SU-85 could follow a target only while that target remained inside a narrow wedge directly in front of it. Once the target crossed that wedge, the driver had to turn the entire 32-ton vehicle. Tracks bit into the ground, dust rose, the engine note changed, the hull moved, and a hidden firing position announced itself. That narrow traverse was more than a mechanical limitation. It meant the crew had to decide where the fight would happen before the fight began. The second sacrifice was armor. The frontal plate remained about 45 millimeters thick, roughly 1 3/4 inches. The same Tiger the SU-85 was built to kill could penetrate far more armor than that at ranges beyond 2,000 yards, so the range equation was brutally uneven. The Tiger could destroy the Su-85 from well outside the distance at which the Soviet gun could reliably penetrate the Tiger's front. The Su-85 did not balance that equation. It avoided it. The vehicle had to fire from concealment, strike a flank if possible, and change position before the German crew identified the muzzle flash. Ambush was not merely a tactic for the Su-85. Ambush was the design translated into doctrine. The third sacrifice was vision. The low casemate made the vehicle harder to see, which was useful, but it also gave the four-man crew a restricted view of the battlefield. In a machine that depended on detecting danger first, poor all-around observation was a deadly contradiction. Still, the design brought real advantages. The Su-85 used the proven mobility of the T-34 chassis. It could make roughly 34 miles per hour on a road. Its range was sufficient to move with Soviet mechanized formations. It carried 48 rounds. The standard BR-365 armor-piercing shell left the muzzle at roughly 2,600 feet per second. A faster subcaliber round could reach approximately 3,400 feet per second and deliver much greater penetration at short range. Those figures did not make the Su-85 invulnerable. They made it relevant. Soviet self-propelled artillery regiments received 16 Su-85s, organized as 4 batteries of 4 with a TT-34 used as the command vehicle. These regiments were not supposed to lead the charge. They were supposed to follow armor, cover exposed approaches, and move quickly to places where German counterattacks were likely to appear. The ideal firing distance was close enough for the 85mm gun to work, but far enough for concealment and the first shot to matter. The crews were being trained to fight inside a very small window, a window measured in angle, distance, and seconds. The first regiment to receive the new vehicle reached the front in early October 1943, barely 5 weeks after production began. The clearest early combat record came from the 1440th Self-Propelled Artillery Regiment. It had already fought with Su-122s and Su-76s. It knew what thin armor and limited gun arcs meant. Then it re-equipped with the Su-85 and entered the Piatikatka offensive on October 15. The operation pushed west from Soviet bridgeheads over the Dnieper, through autumn mud, broken rail lines, and repeated German counterattacks. By the end of that fighting, the regiment reported losing 5 85s. It claimed 18 German tanks destroyed. 6 were identified by Soviet crews as Tigers. That claim must be handled carefully. In 1943 and 1944, Soviet battlefield reports often used the word Tiger for more than one kind of German tank. At distance, through smoke, dust, and a narrow optic, a late Panzer IV with side skirts could appear heavier than it was. No complete German loss record has been matched to those 6 vehicles. So the honest statement is not that the regiment certainly destroyed 6 Tigers. The honest statement is that it claimed 18 tanks, and believed 6 of them were Tigers. That distinction matters. But the physical evidence on the Soviet vehicles matters too. Every surviving Su-85 in the regiment had been hit on the front. Some impacts left dents close to an inch deep in armor less than 2 inches thick. Repair teams welded damaged plates and returned vehicles to service. The Su-85 had been designed as a machine that should not survive a direct hit from a heavy German gun. Yet some did. Not because the armor was strong. Because angle, range, defective ammunition, and battlefield chance sometimes gave 45 millimeters of steel one more chance than the mathematics promised. The crews also reported the distances at which their gun worked in combat. Against the front of a Tiger, they trusted the 85mm gun at roughly 600 to 800 meters. Against the side, they believed they could win from approximately 1,200 to 1,300 meters. That was shorter than the proving ground result. Nothing had changed inside the gun. Everything outside it had. On a test range, the target was still. The distance was known. The plate angle could be measured. The ammunition was selected. The gunner was prepared. In combat, the target moved. The range had to be estimated. The ground tilted the hull. The target turned. Smoke hid the impact. And the crew had seconds to decide whether the next round would penetrate or reveal their position. The missing 200 meters were the price of reality, and the Su-85 had never possessed much margin to lose. Even so, Soviet commanders considered it the best mobile weapon then available against German heavy armor. That praise came with an immediate demand. They wanted thicker frontal protection, and they wanted a gun that could kill a heavy tank at 1,500 to 2,000 meters. In other words, they wanted the Su-85 to stop being the Su-85. Because by 1944, the vehicle faced a problem more serious than the Tiger, the Panther. The Panther's upper glacis was only a little over 3 inches thick, but it was sloped at 55 degrees. A shell striking that plate did not pass through 3 inches of steel. It had to travel through a diagonal path closer to 5.5 inches, while the slope also encouraged the projectile to deflect or shatter. The standard 85mm armor-piercing round could not reliably defeat that plate. Not at 800 yards, not at 400, not even at point-blank range under ordinary combat conditions. Against the side of a Panther, the Su-85 remained dangerous. Against the front, it had no dependable answer. That changed the meaning of the vehicle. The Su-85 had been rushed into service to defeat Germany's most frightening tank. But Germany built only about 1,300 Tiger I tanks during the war. It built roughly 6,000 Panthers. More than 2,000 Panthers appeared in 1944 alone, the year the Su-85 did most of its fighting. So the emergency weapon could threaten the rarer German heavy tank, while failing against the frontal armor of the German tank it was increasingly likely to meet. The Su-85 had not become useless. It had become conditional. Against a Panther, the crew needed a flank. Against a Tiger, it needed a closer range than the Tiger needed. Against either one, it still needed the first shot. The machine was now more dependent than ever on its original prediction. The enemy had to enter the narrow part of the battlefield the Soviet crew had already chosen. Throughout the Ukrainian campaigns of 1944, Su-85 regiments continued to do valuable work. They moved with mechanized corps. They covered advances. They punished German counterattacks. They fought near Kirovograd in January, then through the Uman-Bodosani offensive in the spring. But the Red Army was already building the vehicle that made the Su-85 unnecessary. The T-34-85 carried an 85mm gun in a full rotating turret on the same basic chassis. It offered comparable firepower without forcing the entire hull to turn every time the target moved outside a 20-degree arc. The Su-85's one clear reason to exist had been heavier firepower than the medium tank beside it. Once the medium tank received the same class of gun, that reason disappeared. The real replacement was the Su-100. Its 100mm D-10S gun came from another weapon family originally built for anti-aircraft work, this time a naval gun lineage. Once again, Soviet engineers took a weapon intended to shoot upward and pointed it at German armor. The larger gun changed the range equation. The Su-100 could defeat heavy vertical armor at distances where the Su-85 had been forced to hide and wait. More importantly, it could penetrate the Panther's sloped front at practical combat ranges. The plate that had been effectively immune to the 85mm gun was no longer immune. The hull remained familiar. The industrial base remained familiar. The tactical problem changed because the gun finally changed enough. There was still a gap between the old weapon and the new one. To cover it, Uralmash produced the Su-85M in late 1944. It combined the improved Su-100 hull with thicker frontal armor, better commander visibility, and more ammunition storage. With the old 85mm gun, 315 were built. The Su-85M was an admission made in steel. The armor had needed improvement. The vision had needed improvement. The ammunition capacity had needed improvement. But the gun was still waiting to be replaced. Production of the original Su-85 ended in November 1944. Approximately 2,650 had been built in 15 months. That is not a long production life, but it was long enough to cover the most dangerous interval between the appearance of German heavy armor and the arrival of a better Soviet answer. The Su-85 was never the equal of the Tiger in a fair exchange. It was not built for a fair exchange. It was built to reach a tree line first, to aim at a road before the German column appeared, to fire into a flank, and to leave before the return shot arrived. It gave Soviet formations a mobile 85mm gun when they needed one immediately. It killed tanks. It trained crews. It exposed every weakness that the Su-100 would have to correct. And it proved something harsher than the legend of a Tiger killer. A weapon does not have to be balanced to be useful. It has to arrive before the gap it was built to close becomes fatal. The Su-85 was a gun mounted on a prediction. In 1943, that prediction bought the Red Army time. By 1944, the enemy had changed the question. 17 days had bought an answer. They had not bought the future.